Alright, ladies and gentlemen, this is 6-5 Notes, weighted averages. Your objective, you'll be able to determine the final grade of a course using weighted averages. Use weighted averages to solve real-life scenarios. So, as you would expect, in our current math grade book, I use these things called weighted averages to help balance out the scores and try to make things as fair as possible when evaluating you, the student. Now, for example, our tests and project grades, they're worth 40%. So that means whatever you do far as on your tests and on your projects, it's always going to be worth exactly 40%. Quizzes are normally 30%, so that means by the end of the year, quizzes are going to weigh exactly 30% of your grade, of your quarter's grades. Homework is 20%, no more, no less, and classwork is no more, no less than 10%. So that's just one example of weighted averages and how you're using it already to help determine what your grade is and how efficient you are with your math ability. So let's do some examples here. I know Ms. Herzig and I have been waiting a long time to do these type of problems. The table below shows the test grades for 7 algebra students. We got Bob, Jake, Susan, Rosa, Jamal, Mel, and Pam. The final test is going to count for 4 test grades. Your goal is to write an expression to find each student's weighted average final grade, rounded to the nearest whole number. In fact, we're going to simplify that down. We're just going to focus on Rosa, because right here, they say in this question, what is Rosa's weighted average? So let's focus just on Rosa. Now this is going to be 4 times the amount, this final test grade. So that means this Rosa's final test grade right there is going to count 4 times. So what does that mean in English? Well, our test 1 is going to be 74. That's what she earned. So it's going to be 74. Plus her second test, which is 65, plus her third test, which was 85. Those first 3 scores get counted into her final grade. However, the final test is going to count 4 times the amount. That just means this 83, our final test grade, is going to be counted 4 times. So 85 plus 83 plus 83 plus 83 plus 83. It gets counted 4 times. Whoop. As you can see, the plus 83 happens 4 times. Now, just like we did before on regular averages, we're going to add them all up and then divide by the amount. So, we do 74 plus 65 plus 85 plus 83 plus 83 plus 83 plus 83. We divide by 1, 2, 3, 4, 5, 6, 7. We're dividing by 7 because there's 7 test grades that are being averaged out here. So we put that in our handy dandy calculator. 74 plus 65 plus 85 plus 83 plus 83 plus 83 plus 83, which gets us a total of 556. Then we divide that by 7, and we're going to get 79.428. So that's equal to 79.428 ... That number, when we round it to the nearest whole number, unfortunately, 4 is lower than 5. It's 5 or higher that rounds up. Since it's just 0.4, we just cancel it out. We just let it be. And our final answer is just going to be 79 when we round it to the nearest whole number. So our answer is B for this first one. Now here's part 2 of this question here. Now if Rosa's final test grade was a 100, so using those same numbers, if that final test grade was 100, would she have earned a 90% or higher in the class? So if we look back, And what we got to do, we got to take our work we did before. I'm going to post it right here. If we change all those 83s into a 100s, does she earn a 90%? So that means all these 83s turns into a 100. So 83 turns into 100. This 100 turns into an 83. This 83 turns into a 100. And this 83 turns into a 100. We divide by 7 because there's 7 test grades altogether. We put that into the calculator and we'll see if we get a 90. So 74 plus 65 plus 85 plus 100 4 times. Which we get 624. 624 divided by 7. That in fact gets us an 89.14. So equals 89.14. And 89.14, unfortunately, that doesn't round up to 90, so that's going to be a no. It doesn't round up. Oh, that's incorrect. All right. So, I'll fix this. This is supposed to be a no. That's going to be B. No, they would not have earned an A in the class, Rosa. Close, though. All right, let's talk about a dinner party. Jason ordered dinner for a house party of 40 people. 8 people ordered the $5.27 chicken dinner. 15 people ordered the $3.27 fish dinner. And 17 people had the beef dinner at a cost of $2.11 each. What is the average cost of each dinner at Jason's party? So what we got to do here, that's a total of 40 people. That means on our denominator, we're going to divide by 40. 8 people ordered the $5.27. So we're going to do 8 times the $5.27. So 5.27. 15 people, so plus 15 people ordered the $3.27. So it'd be 15 times $3.27. Then plus the 17 people that ordered the beef dinner, which is 2.11. We put that into our handy dandy calculator. I do open parentheses. 8 times 5.27. Then plus 15 times 3.27. Plus 17 times 2.11. And then I divide that by 40. And we get an answer of 3.177. And that's our answer, 3.177. We round it up and it turns into 3.18. Because $3.17 0.7, well, you can't have 0.7 of a cent, so you round it up to the 8. So 3.18. Alright, let's move on. Here's another example of the weighted averages, and now we're going to find MELS. So you just got to make sure you read this all very carefully. So we're working on now with MELS grades. And that final test score is going to happen twice. So that means 93 plus the 67 plus the 90. And then the 66 is going to happen twice because it's going to be weighted twice. So plus 66 plus 66. There's a total of 5 grades. So we're going to divide by 5. We put that into our handy dandy calculator. And we're going to get an answer of A, 76. That's going to be our final grade there, 76. So you can see that grade, that 66 for the final test really brought her down as far as her overall grade. Now what if Mel got a 100? Well, I'm pretty sure she'll probably pass. So we're going to just replace those 66s with two 100s. Add up those numbers and then divide it by 5. I bet it's going to be over 90. Let's find out. Let's do that one together, just in case. So we got the 93 plus the 67 plus the 90 plus the two 100s. Let me divide that by 5, and we should get 90 as an answer. So Mel will earn 90. Then with this chicken dinner, it's the same story again, except now it's 25 people. Since there's a total of 25 people, 25 goes in a denominator. 4 people ordered the chicken, so it'd be 4 people times the 568. And then we're going to add the 3 people times the 835 meal. Then we're going to add the 18 people times the 614 dinner. And then divide it by 25. We're going to get an average of $6.33 per person, which is B. There's a different problem. Jason purchases $64.40 in groceries. If the sales tax is 7%, what is the total cost of the groceries after the tax is added? So that means you're going to add 7%, so $68.40 plus the 7%, so plus 0.07 times the total amounts of $68.40. We're going to find out what that equals. So we take our total plus 0.07, because that's what represents 7%, times the 68.40, that total again. And we're going to get $73.19. Something was off on the computer. Or did I type it in? Right. Yeah, I got 73.188. So the closest one is B. Alright. Here's another problem, So you can keep practicing. Let's see if we get... Oh, here's one last little different problem for us to look at here. A tea company sells blended tea for $35.85 per pound. To make blackberry tea, dry blackberries cost $27 per pound, are blended with black tea that costs $8.85 per pound. How many pounds of black tea should be added to 8 pounds of dry blackberries to make blackberry tea? So this is a pretty challenging bit of work here. We got to find these ratios, aka the weighted averages here. So dry blackberries, number of units, the price per unit. For a total price of $216. Your black tea, which is W, is what we're trying to find. We know it's $8.85 for every one of them that we buy. So now, W times 885, that's going to be the total price if we multiply those two together. 8 plus W gets a total price of $35.85 for a total price of $249.19. So what we need to do, we know that 8.85 times W plus the 216